This conference will now be recorded.
Vamos a hablar un poco sobre cómo realizar un análisis completo de edificios, ver resultados de análisis, diseño de losas reforzadas, en fin. Es un webinar bien práctico, donde estamos hablando básicamente del modelado de análisis y diseño 3D para proyectos de uno o varios niveles con ADA. Así que sin más, pues los voy a dejar con el ingeniero Nate. Este webinar va a ser en inglés, pero estoy seguro que le van a sacar bastante provecho. Cualquier dudita o algo que no puedan escuchar bien o no entiendan bien, pues escríbanos en el chat, que vamos a estar aquí al pendiente para atenderlos. So, hello, Nate. Do you hear me?
I can. Can you hear me?
Yes, perfect. So, it's all of you.
Okay, fantastic. Well, let me share my screen.
Perfect.
Let me know when you guys can see it.
I think so. I see that. But
yes.
Let me see the
Yes, it's okay.
Okay, fantastic. It should just be the building design using Adapt Builder. So thank you, Carla, for the introduction. I really appreciate it. As she mentioned, my name is Nate Spurley, and I'm a sales engineer at RISA. With our limited time today, I'll be briefly discussing some of the features available in Adapt Builder for building design. I'll start out with a few slides giving a general overview of the capabilities and uses of Adapt Builder, and then I'll go ahead and move into the program to show some of the features in greater detail. So what exactly is Adapt Builder? Adapt Builder is a three-dimensional finite element solution for building design in concrete, post-tension concrete, or a combination of the two. Adapt Builder allows you to model and analyze a complete 3D building from foundation to roof, all within the same model. Specifically, you're able to analyze and design waffle slabs, beam and slab systems, podium slabs, and transfer slabs. Adapt Builder also gives you the ability to do full structural and multi-level structural analysis and design, including load takedown, lateral loading, column design, wall design, and wall design. This allows you to get a better idea of the as-built behavior and design requirements of your structure. Having multi-level functionality allows you to bring all the loads and actions down to the base of your model so that you're able to design the shallow foundation systems. These include mat foundations, pile-supported foundations, specifically pile caps, spread footings, as well as grade beams. Adapt Builder integrates with other platforms, making it easy to incorporate your existing workflows. You can import geometry from AutoCAD and Revit to construct your model, and then export the drawings directly from Builder. From eTabs and Tekla, you're actually able to import geometry as well as loading and reactions to design within Builder, and then you're able to export the rebar and tendon drawings for your drawing production. One of the workflows that a lot of engineers like to use, and I think is very useful, is this kind of round trip workflow with Revit. So here's a flow chart on how you can leverage Revit with Builder. So what you would do is you would start out with a Revit model, export the geometry to Builder, perform the design to obtain the PT and rebar layout. You'd import the tendons and rebar back into Revit, and then you'd be able to create your plan sheets. So this would ultimately save you a bunch of time with coordinating between your drafters, the redlining process, and make sure, hey, is the information getting transferred over to our plans appropriately. So let's go ahead and open up Revit. Here I have a very basic Revit model. There's some patios with some steps. We have some beams, some openings, columns, everything that you'd probably see in a typical multi-level structure. If I go over to the Analyze tab, I've installed our Revit link here for Adapt Builder, so I can click Export. Here I'm able to specify whether I need to use custom column parameters or if I can use the defaults. In this case, we'll just keep the defaults. On this window, we're able to pick what levels are going to be exported. Now, this side of the Revit link is more of a read-only portion. Once we go to importing the Revit model to Builder, we'll have a little bit more flexibility on picking and choosing components and levels that we want to import. Here we can ultimately select what we want Revit to write to what we call an IMP file, which is read by Builder. In this case, none will just import everything. The structural will only import the levels that are assigned as structural levels. Anything that is attached to a non-structural level will not be imported. And then the active, which is the one that I typically recommend that you use, will import only the active structural levels. So we'll select that. On the Components tab, we can kind of see a rough count on the number of items that the export tool is picking up. As you can see, we have 31 walls, 10 slabs, 29 beams, etc. We don't have any load cases in this model, so there's nothing to do there. We do have some load combinations, but I'm going to go ahead and remove these and do them within Builder. So I can select them all and simply just move them over to this side. And then we'll go ahead and click Export. We're going to save the file. And just like that, we've created our IMP file. And we can actually set aside Revit for the rest of this, as we won't need to be coming back in here until we actually do some import. So let's go ahead and open Builder. So on the initial splash screen, you can click this drop-down arrow and you can select the different modules that you want to open Builder with. In this case, since we have a multi-level structure and we're going to be wanting to analyze the single floors, we're going to turn on Edge for multi-level and Floor for our single level design. We're going to do some PT modeling and design in here, so we'll turn on the PT aspect. The program is actually smart enough to determine if a area of the building is reinforced concrete only, or if it's also, if it should be designed as PT. So you can open it like this and design the whole structure as RC if you want, but in this case we use PT. We won't worry about these modules here. The PT shop is useful for generating your shop drawings, your chair heights, your tendon elongations, all of those things. I'm going to go ahead and use US system units. That's what I'm most familiar with, but you can switch to SI if that is your preferred method. So go ahead and click OK. Once Builder opens, we're presented with a ribbon-based UI. It works logically from left to right, so that in a sense you need to create a model before you can add loading, and so on and so forth. In the middle of the screen is our model space where we will see our building geometry and even some results. And then at the bottom of the screen, we have our quick access toolbar, which has a lot of the features that you're going to be using pretty regularly, such as snap tools, different view settings, as well as toggling on and off the display of items. One thing that I really like about Builder is you're able to customize hotkeys. So in this case, you can see I have my snap tools set to Alt-1 and Alt-2 and so on and so forth. And these are completely custom, which makes it so you don't have to learn hard-coded shortcuts in the program. You can make them whatever you want and something that you're going to remember when you come to modeling it. It just ultimately helps you save time and speed up your modeling process. So let's go ahead and import our Revit file we just created. So I go to File, Import. I'm going to click IMP because that's what we just created. I'll select this file, click Open. And this is where we have a little bit more flexibility that we didn't have when we were exporting. Here you can see all of the levels from our Revit model have been included. And we could create a new model with all of these levels, or we could create a new model of just a single level, or we could also update. Notice that here I'm able to actually toggle on and off components. So say one level got changed, the columns moved around, say on level 2, we could go ahead and re-import the columns for level 2 if we wanted. But since this is a brand new model, we'll go ahead and import the whole geometry, create a new model. Loads and load cases, this is blank, as we saw when we first exported. The load combinations, there were some, but I removed them on the first export, so that's now empty. Let's go ahead and click OK. Within seconds, we have a model brought in from Revit. We can take a look at this in an isometric view. You could even go into a rendered view and spin this around and take a look. You can see here we have our beams, our openings, our columns, our walls, and there's even that step on the patio that we saw in the Revit model. So it's pretty quick and easy to get that brought in here. So now that we have our model in here, we don't have any loading or any way of actually starting to design this. So let's go ahead and add some loading. One way I could do this is I can select each slab individually if I wanted by holding Control. I'm not holding Control, there's Control. I could go into a top-down view and kind of window select these. You can see I'm getting a few of them selected there. Or another way we could do this is we can actually select by type. So up in here, I can select by type, and I can select my slab regions. Click OK. And now really quickly, if I go over to the loading tab, I can add some patch loads. These are just area loads. Oh, that's the wrong one. That one would be tracing. So let's go ahead and select our slab regions again. I meant to select our patch load wizard. So this will map a area load to the slab regions that I have selected rather than having to trace over them. So you have the flexibility of, say, if there was a small area on this slab, I could trace that patch load in there if I wanted to. But I'm just going to put some general loads over this slab. We'll go ahead and put 10 PSF of dead load. Let's go ahead and add 40 PSF of live load. Change this to live, click create. Now the scale of this is a little off, so we can actually go into our set view items and change what is being displayed. And in this case, the scale of our loads is a little big, so maybe I reduce this down to, let's try 3. There you can see the loads are much more reasonable. You can see they're actually scaled appropriately. This is probably our live load since it's taller. This is our dead load here since it's a little bit shorter. So we have some gravity load on there. Now in the set view items, I have the ability to save a default display. Right now, my default display, I typically just turn on the geometry. And what that does is it allows me to click this default display button, so it'll clear anything than what my saved default display was. So in my case, it's the geometry, so I click this and the loads will go away. Or they should. There they go. Let's go ahead and add some lateral loading as well. We go into our wind load wizard. You have some parameters you can change here. I'm just going to increase the speed of the wind. You can include an orthogonal direction, can use user defined, include torsional moments. A lot of flexibility in this window. I'm just going to use some basic input. Just like that. There's some wind load in here. If we look at top down view, you can see, hey, we have, windward forces, leeward forces, all of that. We could also add seismic in here if we wanted. Maybe we call this EQX. You can change your parameters. You can even specify user-defined values over on this side, eccentricities, all of that. Let's just apply this. Our view's getting a little messy again, so I'll hit our default display. Now we have our structure loaded. We can go in here and add some load combinations under the loading tab. These are pretty easy. Say I add a strength load combination. Maybe I want this one to be EQX direction. We could add our factors. So I want perhaps 0.9 self-weight, 0.9 dead load. And then over here, I could add my earthquake load that I just created. Maybe we do 1, maybe 1.2. You'd go in here and add your combinations as you would need. You can, once you have these all added, you can actually save a template, and every time you open Builder, those load combinations would be in there. So we'll just click OK. We could add some more load cases if we wanted. Say if we had snow load, you could add that here. Now this screen, you can see that our loads are separated between general loads and building loads, which comes to a very important point within Builder. You're able to, let me switch to the front view. You're able to switch between a single level and multi-level analysis situation. So let's just select maybe level 3, which is our transfer, kind of our transfer level. So right now I'm in multi-level structure or multi-level mode right here based on this selection. So any analysis that I do is going to take into account the behavior of the entire structure. But in PT, you're typically doing an iterative design where you have to come back, change the tendons, analyze again, okay, check your deflections, your stresses, modify the PT a little bit, and then redesign. Now, if you're having to redesign the entire structure over and over again, that's gonna take up some time. So what Builder allows you to do is actually pick out a single level and analyze that level, disregarding all of the other levels around it. So you can keep doing that iterative process. So ultimately, this is going to save you a bunch of time and effort in trying to finalize a PT design. Now, the loading that was back in here, these loads are considered in the multi-level and single level, whereas these loads are only considered in the multi-level. So if I analyze this, I'm not going to be taking into account lateral forces. If I want to, I need to switch to multi-level mode. So let's go ahead and do a multi-level analysis real quick. So I have my loading, I have my geometry. So if I go over to our analysis tab, now we could add some base rebar if we have it. You can use the mesh wizard, which is very similar to the patch load wizard that I used, where I added an area load. This will just trace our slab regions that we have selected. I'll let the program generate all the rebar for us, but you could add rebar if you wanted. So under analysis, let's go ahead and mesh this entire structure. Since I'm in multi-level mode, it's going to mesh every single floor. Now you have some options here as far as how you want the program to mesh your slabs. If you add wall openings, you can use the advanced method. We don't have any, so we'll just stick with the simplified. And then you can specify or change the suggested cell size. Typically, the program will pick this as a good starting point. Sparse will allow you to mesh to a little bit more complex geometry, whereas uniform is going to be much more useful for very rectangular floor systems. I'll keep it as sparse since we do have a couple of jogs in our slab and whatnot. You also have the ability to shift nodes of components. Not everything that you model is going to be perfect, and it's also just a good way, so to speak, to bridge the gap between what you're modeling and what the program is interpreting. So let's go ahead and save and mesh. So the program's going through each slab from the bottom to the top and meshing. You can see our cell size here. Looks a little messy, but that's just because it's all overlapping. We can turn that off very quickly using this tool, or I could use my reset default display. Now let's go ahead and save this real quick. And now that we have a mesh set up, we can go ahead and analyze the structure. So keep in mind, I am in multi-level mode. This is just warning, hey, you added some wind load and the wind load is not applied to any load combination. This is okay, we won't worry about analyzing for wind. So we'll continue. Maybe we use our earthquake load combination that we created. We do our total load as well as our dead and live load. Go ahead and click OK. So now the program is going to go through the entire building analysis for those load combinations and individual load cases. Now take note on the time that it takes to analyze this full building. It's pretty quick, but it still does take a couple seconds longer than when we switch to single level mode later on. So this should be done here very soon. And obviously, the more complex your structures get, the longer this full building analysis will take, just because there is a little bit of an iterative process that's going on. So there we go, we have a full building analyzed. You know, we could go in and see some of our deflections. I don't know if this is going to show much for us on a multi-level scenario. Let's go ahead and see. Yeah, so we can see, you know, our deflections that are going on per level. If I switch to, it's loading a lot of data, so it's taking a minute. But we could switch to a single level and look at the deflections, make sure. Let's go top view. You can see, okay, it looks like our columns and walls are supporting the slab properly. Our slab isn't falling through a wall, or a column isn't coming through the slab. Those looks like everything's connected there. So let's go ahead and clear this display real quick. And now let's go into that. Now that we have a full building analysis, we could actually go into a single level and get into the actual floor design of the system. So let's say this is a reinforced concrete floor on this level. The first thing we need to do is actually go through here and add some support lines. Now you could use our support line creation tool here. This requires you to go through and click over each column and the slab edge. But something that we added, which is I think a very fantastic tool, and I didn't get to use it very much when I was doing more consulting work, is our dynamic Tendon Editor. And all you have to do is simply draw a line through your columns and it'll create the support line. So I'll click and then I press C on my keyboard to close the action. And you can see it's actually created the points at the slab edges and on the columns as well. So let's go ahead and add a couple more here. I'll add one here. Like that. Another one here. And let's do one more in this area. So the reason and purpose for support lines is this is going to set up our tributary widths and our design sections. So the program is going to create cuts for us to design the slab based on the solution that we have created. Now, the tributary regions that are generated from these support lines, they look for three things: a slab edge, a adjacent support line, so it'll split the distance here, or it looks for a splitter. So in this case, this support line doesn't know that its tributary width should end roughly in this area, and it's going to obviously change a little bit. It's going to try and draw all the way to this slab edge. So if we use a splitter, we can tell the program, hey, your tributary area actually should be maybe here. Now I'd go ahead and want to set up, support lines over every single column, over every single wall, in the X direction as well as the Y direction. But for the sake of time, I'll just do this small section here. So now I'm able to generate the sections. And you can see these sections actually stopped at the support line or the splitter that I created, and then also at the slab edge, and then they split the distance between these two very well. So with our analysis results, we can go ahead and design these sections. Now the program is designing for our load combinations that we analyzed in the full building, but just for this single level. You can see here over in our analysis results, we have a new drop-down with design sections. So we can go in here and check our bending moments, for example, our shears, axial forces. We could even check our span to deflection ratios. Everything in green is saying, hey, you meet the span to deflection ratio setup that you specified, and you can change that over here. So right now I'm using L/360. And then on the loads tab, you can switch between the different load combinations that we had analyzed for. So in this case, we're just checking for service total, but we could switch over to, maybe we want to look at our earthquake in the X direction. Maybe we want to check our strength. Obviously, we're not checking for our deflection ratio for strength combination, but we would be for our service. Now, the program has technically not added, but it is calculated reinforcement that is required. So if I go over to our investigation, we're seeing a moment capacity and a moment capacity with demand, and it's flagging it as not good. And the area that's not good is shown by this pink section here. But everywhere else, you can kind of see that the black is the required moment capacity, and then the green and blue are positive and negative moment capacity, respectively. So you can see that there are jumps in the capacity graphs, and that's because the program is going to add rebar there. So what we can do is we can clear this display. Let's get rid of our results as well. And I will hide our support lines so those aren't in the way. And I can calculate a rebar plan. In this case, I'm going to do it for the envelope condition. Click OK. And just like that, we have some rebar. Now, this is only in the X direction because I only specified X direction support lines. But if you did it in the Y direction, you'd also have rebar for the Y direction. So that's how you would go about designing, a reinforced concrete slab, maybe in a multi-story structure situation. But let's say this level up here now is a post-tension concrete slab. So what we'll need to do is actually go through and we'll create some support lines real quick. So in the floor design, we'll do some extra support lines. Now I could actually go down a level below, which I'll do here in a second. Clicking this, I can go down. Let's turn off our rebar real quick. Show our support lines. And technically, I could copy this. I could copy this support line up. Let me close this. And go over to modify. And I can copy this vertically. And I can copy this to all the levels in my building. So if you have a very typical level, you can copy it up a certain amount of times. You copy it down a certain amount of times. In this case, I just want to go up one level. Now if I go back, you can see that support line is added. And in this case, it is too long, so I can actually adjust this using my snap tools. If I right click here, I should be able to delete this vertex. Pretty easy to clean up. Now let's go ahead and add our splitter. We could have copied that one up too, but it's pretty easy to add it here. I forgot this support line. So we'll add one there. Now let's go ahead and say that our X direction is the banded direction for our cables. Now this area is going to be a little weird, so maybe this section is only treated as reinforced concrete, traditionally reinforced concrete. What we can do is we can click the support line here, go over to our tendons, and we can map distributed or banded tendons. In this case, I'm going to do banded because this is our banded direction. You can enter the tributary width. Right now I don't have a design strip width, so let's actually go ahead and do that. I go over to floor design, need to generate our sections real quick. Program is giving me an error. Let's see real quick. Should be okay. There we go. So it looks like it's not picking up this splitter properly, or this support line, which is a little interesting. Not sure why that's happening, but we can force this by using a splitter. Let's go about here. Try that again. Still not happy. Not sure what's going on there, but we could look into it a little bit more. It might be that this is sticking out a little bit past it, but let's go ahead and maybe we'll go back to this level, and we'll design this level as PT now. So let's go ahead and map a tendon. We'll map it banded. We'll use the design strip width, and we can idealize this as a group of tendons with an offset. We'll go ahead and do that. Let's have it offset 2 feet. We're able to specify what our pre-compression is going to be with a minimum and maximum for the program to target. Let's up this a little bit so that we can meet code requirements. And then we're able to specify a self-weight balance. Now, this isn't really a code requirement in the ACI code, but depending on these values here, what you set, the program is going to adjust the tendon profile and drape to maximize uplift in a very big span and minimize uplift in a very short span so that your PT effects are contributing appropriately. You're also able to specify what the first span should be, if you want it to be a reverse parabola or cantilever down. So in this case, our first span should be this span over here, and we're going to want that one to be cantilever down, so I'll change that. And then the rest of them should be okay with a reverse parabola. So let's go ahead and click OK. Now, it looks like it only created one tendon. Maybe I didn't specify. Let me try that again. Map ended. Wanted, idealize as 2 groups. Misread. There we go. That's correct. Now we have 2 tendons. It's kind of what you would typically see on drawings. Now, this is a little bit of cleanup here, not difficult. You can just click here. You can right click and delete a vertex like we did earlier, or I can click the tendon and there is a delete point here. So that's easy. We can see how many tendons are in here. There's 16 strands there. We could open up the stressing, whether we want to use effective force or the actual stress calculations. We can see the drape here. This last span looks like we need to do a little bit of cleanup there. But notice how the heights have actually been adjusted. Obviously, this really long span, the 65-foot span, which hopefully ends up working in our design, has lowered the profile, whereas in the shorter span, it's raised it. So this is so we prevent the pushing of our load over into this already critical span by raising the profile a little bit. So let's go ahead and adjust this. I just delete this outside point, and same with this one. And then there's a very useful tool where I select the tendons and I can trim and extend them to the slab edge instead of having to drag them out. So just like that, that's done. So there we have a banded direction. You know, we could do another one here real quick. Maybe we'll just have this one as one group of tendons, and we use the tributary width. We don't want this to be cantilevered down, so we'll change it back. Click OK. Put it outside the slab edge. That's kind of funny. Not a problem. If I modify, and I can do transformation by coordinates, I can move this down, let's say, -3 feet. There we go. Now it's kind of over our columns. We'll clean this one up real quick. Delete this tendon point. That one doesn't have one there. Maybe we want to change that one to cantilever down, but we'll trim extend. Sorry. Now, we could go into each individual tendon like I showed to adjust the profile. With a lot of tendons, in this case we don't have a lot yet, it's not very difficult, but with a lot of tendons, it becomes a little tedious to individually click through them. So if we go over to our tendon toolbar, you can go into our Tendon Editor. Now this makes it really easy to adjust our CGSs. You can see them here on plan. Maybe I want this one to be a little bit lower. Maybe I don't like that 1/4 of an inch. For the drawings, maybe I want this to be 3 inches. So I can do that and then simply window select that, and instantly it updates those CGS. Now I can do the same with the number of strands that are being used. I can change the forces. In the modes, we can actually change if it's a straight line tendon, a spline. The spline is useful if you have an opening and you need to actually swerve this tendon around the opening. I can show you how you can do that here in a second. And then we can actually change the shape. So we want this one to be cantilevered down, which is what's selected. So if I change it just like that, very quick and easy. You can see in our shape and system, it's now cantilevered down, centered or anchored at the CGS of our slab. You probably want to add some tendons there, or we could even sweep these, but get as creative as you want with our PT. Now, in the other direction, we're going to want to have our distributed tendons. Now, what I like to do is I like to simply just add a single tendon, and I call this the master tendon. So what I'll do is use some of our snap tools here. Actually, I'm just going to snap to the center of this column for now and draw this tendon out. I'll snap to this beam because it's considered a support. Snap to perpendicular there and there. So I have a tendon. We'll use our trim extend. Now let's adjust this profile to something that we think is going to be adequate. Now I'm going to do about a 4-foot tendon spacing, and this slab is 8 inches, so I'm going to need about 2 strands every 4 feet. So we'll change that to 2. If I go over to the shape, this looks okay. You can actually see over here that the program is picking up our balcony with the slab step, and it's adjusting the CGS appropriately for the tendon. Let's go ahead and just leave the drape as is, and then we can go through and adjust it if needed. So click the little green check mark. That'll accept those changes. So if I go here now, I can go back to our modify, and I can do the translation by coordinates tool. Let's have this, like I said, we're going to have it spaced every 4 feet. And let's copy this over, maybe, let's start with 5 times, not get too ahead of ourselves. So if I copy, here you can see I quickly copied a bunch of tendons. Pretty easy, so needed a little bit more. So let's do it again. Let's go for 4 feet, 5 tendons, copy. Now this one we could adjust if we wanted. You could move it over a little bit. If you wanted to swerve it, you could do that. That'll work just like that. Now let's go ahead and analyze this. I would go through and add all the tendons, and as you saw, if I copy this one over, I can trim extend it. I can add some spans by the right clicking and adding some vertexes or vertices and whatnot. I mentioned swerving the tendon. Let me show you that real quick. So if we say have an opening, where's my opening? I can quickly add an opening, let's say right here. A horrible spot for an opening, but let's say there's one there. And obviously we don't want these tendons going through there. So if I go back over to the tendon tool, I can insert what's called a swerve point. But first I need to change this to a spline tendon. Same with this one. We'll select this, and now we'll insert our swerve point. Let's add one there, and maybe one there. And we'll select this one, and we'll add one here and one here. What I can do now is I can grab these swerve points and actually move the tendon, and notice how it's actually swerving. Probably more like what you would see on the job site, because there's always a bunch of holes in our slab systems, right? So you can do that, you can adjust it, go through, move them. And what's really cool is this has not impacted the vertical change. Now there's a little bit of a visual glitch here, but the profile is actually still correct, and it's taking into account this horizontal sweep. So when you come back through and say doing your PT production drawings and you need the length of this tendon, it will take into account not only the drape, but also the horizontal sweep. Now, later on, we're also able to show where we need hairpins based on the curvature. Actually, we might be able to do that now. Let me see. Now it looks like we need to, oh yeah, so everything in green says it's okay, whereas if this gets a little bit more extreme, maybe I can't make it extreme enough, it'll start to show, hey, you're gonna need hairpins here to prevent this tendon from bursting through the concrete or pulling through the concrete. So very useful tool there. Now, I don't want this opening. We'll just delete these swerve points real quick. So added them very easily. I can remove them just as easily. We'll return it kind of back to the way it was. Now let's say we're just wanting to finalize the gravity design of this floor system. What I can do is I can analyze just this floor by itself, including the PT that I have in here. So if I execute the analysis, remember we've already meshed. I'm now in single level mode rather than multi-level mode. I can click execute analysis. Again, the program's warning me, hey, you have wind load, but the wind load isn't assigned to a load combination. That's okay. There's no use in us using the EQX because we're in single level mode. So let's just analyze these two load combinations. Now pay attention to how much quicker the analysis time takes. We've added PT, which is going to take up some analysis time, but we're not analyzing the entire structure. We're just checking this one floor for gravity design. And you'll see it goes significantly quicker, or at least it should. And just like that, we're done. So much, much quicker. And we could go and check, let's pull up our design sections that we have. Remember, we only have them in the X direction. I'm going to go ahead and turn our tendons off. And now we can go into have our service total load combination selected. We can go over to, oh, I need to design the sections. So right now we only have the analysis for the floor system, so that would only give us deflections. But if we want to get our actions and stresses, we need to design the sections. And it adds that design sections there. So now I can go in here and check stresses. And here you can see, hey, look, our bottom stresses are good. So the amount of tendons that the program picked for, our banded direction, just based off of the support line was pretty close, but let's see what the top looks like. You can see, okay, we have a little bit of stress issue here. Now we haven't checked this for punching shear. We could do that because maybe these columns actually need to be increased in size, and that may have been a more logical step to go about doing before this. So let's see what our punching shear looks like. Let me clear the display. We're going to select a strength combination, go over to our punching shear in our floor design. So here you can set, your punching shear parameters, and I didn't talk about this at all, but you're also able to, set your design code, your preferred rebar bar lengths and sizes, other analysis design options, as far as, hey, how do I want the structure to be fixed when I'm doing single level versus multi-level? What's our support condition? You can change that here. You can specify your allowable stresses based on code, your tendon height defaults, all of those things, just to save you some time. Maybe you have some fire requirements as far as, hey, we need to make sure that the tendon has adequate coverage for in case of a fire. You could adjust this here, increase it so that it's not so close to the slab surface or whatnot. So very briefly touching that, we could spend a lot of time in there, but I'm just using the defaults. So let's go ahead and execute our punching shear. Very quick. Now, if we go over to our analysis tab, we have a new drop down for punching shear. We can go ahead and click. Okay, let's see. Program's saying these ones are okay, but hey, you're going to need to reinforce these. Now, let's see what the stress ratio is. Okay, so it's a little high. What about reinforcement? So these are stud rails for these columns. You can see we have a total of 8 rails, 2 on each side right now, with a total number of 8 studs spaced at 1.5 inches. This is not a ton of reinforcement, so we could go with that, or maybe we go back and say, hey, we need to increase this column, or maybe we add more PT. It's another solution we could go with. So that's kind of up to the engineer at that point on how you want to proceed with doing the satisfying the stress issues that we were seeing here on our top stresses, except I'm in strength combination. There we go. So it's really not that bad. I mean, this, in my opinion, you probably could satisfy with PT, but let's see what our pre-compression is. Maybe our pre-compression is already really high. So you can see here, yeah, the pre-compression is pretty high. Typically in a slab like this, you're looking at no more than 300, but a minimum of 125. So obviously it's going to be really high over here because these design sections are really small. You can see that the PT force, actually the pre-compression starts to drop down in this area, and that's partly due to these walls absorbing some of the PT force. And then also, how we're stressing these tendons. I have a feeling this is a 2N stressed, so you're going to see a lot more stresses at the beginning of the slab, and then those stresses and forces are going to kind of disperse throughout the slab as we get closer to the middle. Now, with that, we could use we have a Tendon Optimizer, which is a good little introductory or starting tool to get some PT a general PT design going. So I could have used this earlier on as well, or I can adjust it here. So let me clear our display and turn on our tendons again. Now if I use our Tendon Optimizer, I can select the span, which was problematic. And notice you can see what's happening is the program is looking at the span here out of reference from everything else with the forces, and it's saying, hey, this is roughly where you need to be. Now, the pre-compression number is high because this tributary width is off, so I'm able to adjust this. Maybe this is closer to, maybe we say 15, not 25, 15 feet. We can update it. And then our pre-compression number still pretty high there, but like I said, this is a very good starting tool to get your PT designs going. It'll give you suggestions on, hey, what total force do you need? What should you adjust the CGS? In this case, our pre-compression. But notice this number doesn't necessarily correlate to the 3D results because this is looking at it almost in just a 2D sense. So again, just a good starting place to get your PT designs up and going, and a good starting place where you can go from there. So we have forces, maybe we say our stresses are satisfied, we could go into our criteria. We could be, hey, let's increase our concrete strength. That'll probably allow us to be within, code requirements. Several different options we could go with in this case. And with the design done at that point, we can generate our rebar and go into our floor design or calculate it here. We'll do it for the envelope. You can see we have a lot less rebar now because it's taking into account the PT. And in fact, if we open up our floor design, go over here and click on the support line, you can see that the program is knowing, hey, there's no PT here. We're going to design this as a two-way RC system. Whereas over here, there is PT, and it's picking up as a two-way PT. And it's simply doing that by if there's a cable crossing over a design section. So like I said earlier, when we first opened the program, you could open it in PT and RC and simply just design the whole building as RC if you wanted, or if you have a combination of the two, like in this situation where this is RC and this is PT, the program will know how to design it based on the code requirements and everything. So, and you can specify that stuff in the criteria as well. So we could actually go ahead and now export this to Revit. I didn't do this a lot in my consulting, so bear with me if it doesn't go as smoothly as planned, but I can show you to the best of my abilities. The one that I normally did was exporting rebar and tendons to CAD, which is very straightforward. So maybe I show you that first. Let me go ahead and turn off our support lines. So you can see we have some CAD or some rebar in here. If I go over to our rebar, I can specify some export settings in this situation. And I'm just going to leave the defaults. Now, if I go File, Export, I can export a DWG. Now I can specify whether the tendon is going to be a polyline or a spline, and then if it's going to fillet and whatnot. I believe the spline option will actually model as a 3D object within CAD, so I'll go ahead and leave it as a polyline in this case. And I click OK. Let me just save this maybe in here. Let's call it rebar. I believe it's also doing the tendons. Apparently there's some issues that it's detecting, so it's not liking the labels that are being applied to our AutoCAD and layers, so we can apply the fix. Now if I go back into Here you can see we have a rebar DWG. Now I don't have AutoCAD open, so it's going to take a minute to open. So let's go back to Builder while that's opening. Let's try and actually export this to Revit. Now, in order for us to export the tendons to Revit, we need to turn on a setting. If we go in here and go into our tendon settings, we need to enable the export tendon segments in IMP. Now, this is automatically off because within Revit, there's no good way of modeling a spline object. So what ends up happening is they get imported as individual segments to simulate a spline. And obviously with a lot of tendons, this can add up to taking a while to create the Revit model. So we have it toggled off just because not everyone wants to go that route, but you can turn it on here. So similarly to how we imported an IMP from Revit, we're going to export an IMP back into Revit. So let's go ahead and export an IMP. We'll use the latest version. Let's call this one maybe tendons. Save. Now, you may have noticed this Revit option here. This is for our older versions of Revit. This wouldn't include any tendon or rebar export, so I'm using our newer one up here. So let's go ahead. Oh, our CAD is done. Let's take a look real quick. You can see as our rebar in there, I could have turned on our CGS and shown those, our strands. Obviously, there's a little bit of cleanup that would need to happen here, but you could quickly apply your style sheets and whatnot to get your drawings. And notice that each of these are actually on their own layer and levels and whatnot. So AutoCAD just froze on me. But we'll go back into Revit and let's try and import this. So let's go File. I could add it here, but just for cleanliness, I'm going to create a new one. So we're going to do a new project. Now it's important that you specify that the model is a structural model. So we'll go ahead and use the structural template. Now I'm not super familiar with Revit, so bear with me. So now if I go into our Analyze tab again, I should be able to import the IMP file that we just created. You're seeing a similar window that we saw at the beginning. Let's do the IMP that we just created. Click Open. So it looks like I must have messed something up on the export, but there's a way to do that, but we're running out of time at this point. So let me get into, oh, I think it is still processing. Obviously there's a lot of data, so we'll see if it gets done in time. But let's go ahead and go back to our model and I can show you a little bit about reports. So, you can generate individual reports as far as slab regions, your beams, your geometry. If you have soil support conditions, in this case, we're not doing any foundation design, but we would be able to do that within the same model. Going back to this initial opening of Builder, we could have selected the map module, which lets us do that. You can create a loading report showing, hatching of where our dead loads are, our live loads are, as well as any other loading that we have, tendon reports, rebar, the punching shear, we can get a schedule if we open our punching shear reinforcement. Here we have a schedule for the punching shear design that we did for that one level, which is pretty useful. And you could go through and individually create the reports, or you can actually use our report compiler. So this allows you to just put one big report together based on the sections that you want to include. So you can just go through here and toggle, hey, maybe I want my structural geometry, which is including all of this. I can add a cover. You can actually go through and have take screenshots within the program using this tool, and those will be included here, and you can kind of move them around and put them where you want. Adjust, your model name, all of that stuff. makes it really nice in the post-processing of things. So that more or less concludes my presentation. You know, we could have been talking about this all day long because there's so much to do within this program. But let me put up our information so you can kind of see that here. Again, I appreciate everyone's attention over this brief overview of Builder, the robust and easy to learn finite element solution for concrete building design. Hope that you learned how Builder can save you a bunch of time and effort on your concrete designs. Again, if you're wanting to learn more, feel free to reach out to us. We'll be happy to help you. We want to answer your questions and see how we can help. That's our goal. We want to make life easier for engineers because we know it's not the easiest thing in the world, whether that's both on the design and the post-production side of things. So thank you all. Carla, I'll turn it back to you.
Thanks very much, Nate. There are some questions, but Carla already responded that. So I don't know if maybe there are another person who wants to ask something. Let me see. No, for now. Only two persons, and it's already responded. But thank you very much, Nate.
Thank you.
It was very good, the presentation. And okay, give me a moment. Okay, one question. Here said, is you can import a structure model from StatPro, SAP 2000 ETABS, and others.
Yeah, so right now we have ETABS. That's the only one. Here is our, let me go back to our integration.
Okay.
So we have ETABS and Tekla for geometry and loading, and then AutoCAD and Revit for just geometry, obviously.
Okay, perfect. Yes. I don't know, Carla, ¿quieres aprovechar de comentar algo? Disculpen, al principio de la presentación no les comenté que nos acompañaba también nuestra compañera Carla directamente de Risa. Ella también está apoyando en esta presentación junto a Ney. De hecho, es la persona que ha estado adelantándose a responder las preguntas. Muchas gracias, Carla, también por el apoyo. No sé si quieres comentar algo antes de finalizar el webinar. ¿Me escuchas? Bueno, creo que Carla tiene problemas con el micrófono. Bueno, queríamos despedirnos. Muchas gracias a todos por la participación. Igual si tienen otras dudas nos pueden escribir en el correo. Ahí pueden ver el correo directamente de Nate. Y en el chat está nuestro correo. Igualmente le vamos a estar compartiendo información para todo lo que necesiten. Thanks very much, Nate. Welcome again for another webinar.
Thank you. And again, if you guys have questions, feel free to reach out to us. And then we also have several YouTube videos at the site that I have on the screen right now. There's a lot of useful tutorials and specific videos on a lot of the features I didn't cover, such as wall design, column design. Again, we could have been here all day with all the features that are in this program, but I wanted to kind of just get everyone's feet a little wet and see, hey, what can it do and how easy it is to use.
Perfect, perfect. Thanks very much. Have a good day to everyone. Bye-bye.
Thank you.